Alrighty, so today we're doing exercise 3J, which is solving simultaneous equations algebraically. So in the last video, we looked at solving simultaneous equations graphically by graphing the two lines, seeing where they intersect and that coordinate being the solution. So today we're looking at two different methods, so when you don't graph them, and we call it algebraically because it's using the skills that we've already looked at by solving a lot of the equations and transposing equations to get the variable that we want. Okay, now there are two different methods we're looking at today. Number one is called the substitution method, and number two is the elimination method. So, looking at the first method, substitution can be used if one of the equations is in the form of y equals mx plus c. So, technically, it doesn't have to be, sometimes you might have the c and the mx around the other way, but what you really want is the x and y on different sides of the equal sign. If it's looks like that, then you can use substitution. So, the process. The first one is number the two equations 1 and 2. Then you can substitute the equation in the form into the other equation. Then you expand, you solve for x. Once you find x, you substitute it back into the original equation to solve for y. So it'll make more sense in an example. So here we go, simultaneous equation. So remembering two things happening at the same time. So we've got two equations here, and we're going to label them 1 and 2. Okay, or they've done it in this step actually. So, like number 2 says, substitute the equation into the form, in the form y equals mx plus c. Okay, so for this one, it says we're subbing equation 1 into 2, because with equation 1, it says y equals 5 minus 2x. So in the other equation, so the second equation, we're going to put 5 minus 2x instead of the y, because that's what y equals from that equation. Okay, so back over here, we've substituted the first equation into the second, okay? Instead of the y, we've put what it equals, which is that 5 minus 2x. Number 3 says you need to expand the brackets and collect your like terms. Okay, so that's what we've done here. So expanding the brackets, you've got negative 2 times 5 and then negative 2 times negative 2x, which is this line. Okay, and collecting all your like terms, so you should end up with 7x minus 10 equals 4. So from here, like step 4, okay, it says to solve for x. So you can use your inverse operations. So here you've got a minus 10, so you're going to plus 10 to both sides. And then you're going to divide by 7 on both sides. Okay, and that's what this box here is showing you. So eventually you should get x equals 2. Okay, so the reason we've done that is now that we know one of the variables, we can now substitute that into, you can choose either of the equations. The first one was probably the easiest in this one. So that's why it says here, sub x equals 2 into equation 1. Okay, so equation 1 was y equals 5 minus 2x. So instead of the x, you put the 2, which is this step. Then you solve it. So negative 2 times 2 is negative 4. 5 minus 4 is 1. So y equals 1. Now, number 6 says you can check your solution to make sure you did it all right. You can substitute your variables back in. So like I said, when we had x equals 2 and y equals 1, if we substitute those into one of the equations, so in this example, they subbed it into the second one, okay, you should get the same number on both sides. And for this one, we did, because 6 minus 2 is 4, and that side is 4. So we know we got it right. Okay, so that means that the solution to these two equations, so when they both equal one another, the solution is x equals 2 and y equals 1. Okay, so it's kind of like if you were to graph both of these lines, they would intersect or cross over at 2, 1. Okay, so we've just done it algebraically by using the substitution method. We're also going to look at the second method. So, oops. This is just another example of using the substitution method, so I'll let you guys have a look through that. We're going to do the method 2 of elimination as well. Okay, so elimination can be used if both the equations are in the form this. So what that means is the x and y are on the same side. Okay, should be using my highlighter. So if both of your equations, the x and the y, are on the both same sides, you use elimination method. And what that means is that we want to eliminate one of the variables, x or y, doesn't really matter. And you can do that by like manipulating the equation. And what I mean by that is that if you are to add or subtract the equation from the other equation, you want to eliminate one of the variables. Okay. Equations can be rearranged so x and y are on the same side if you would like to use this method. That's just a little side note. Alright, so if you were to add or subtract the equations together, you want to get rid of one variable because it will help you find the other variable. So just a bit of the steps so you guys can follow this whenever you're doing one of these questions. You number the equations again, same as the other one. Number 2, look at the coefficient, which is the numbers in front of the letters, and the sign, so whether it's a plus or a negative, okay, in front of x and y. If coefficients are the same number, follow A or B, so down here. But then there's the point, if coefficients don't match, you need to multiply the whole equation by a common factor. So there are a couple of different steps here. So if it says, if for A, when variables have the same coefficient but different signs, you add the equations together. If they have the same coefficient but the same sign, you subtract or minus them from each other here. It doesn't really matter which way you go, whether you do equation 1 minus 2 or 2 minus 1. Use inverse operations to solve for x and y or y. Once you find one of them, you substitute it back into one of the equations to solve for the other variable, which is y, or x, depending. You can then check your solution and then you need to state your solution. So for an example for this one, firstly, you can tell that we're going to use the elimination method because the x and the y are on the same side. Okay. First step, number the equations. So we've got 1 and 2. Okay, look at the coefficient and sign in front of the x and y. Okay, so it's like in front of the x and y for equation 1. Remember there's like a secret 1 in front of them if there's nothing there. Right, so they've both got a positive 1 in the top bit, and the second one, the coefficient is 2, and the one here is a negative 1. Remember there's a negative in front. Okay, so you can do a little table like this if you like, and you can see here that coefficient of y have the same coefficient. Okay, they're both 1. Their signs are different, which means we add the equations together. Okay, just like up here. So adding them together, you literally, you can set it up like this, okay? So x plus 2x is 3x. Y plus negative y is 0. So that, see how y is now eliminated? Okay, and that's the reason we're doing this. And then we go 3 plus 9, which is 12. Okay, so we get 3x equals 12. So from here, we solve for x, which means we would divide both sides by 3, and you get x equals 4. Once you know that, you substitute x equals 4 back into one of the equations to find out what y is. So for this one, we've substituted back into equation 1, so you'll have 4 plus y equals 3. To find y, you need to use the inverse operations, so y equals negative 1. Okay, you can check your answer. Once you do and you see that it's correct, you need to state your answer. So x equals 4 and y equals negative 1. So that is the solution to these two equations. This is an example when coefficients are different. So you can do your little table here again. Okay, the coefficient, I'll highlight them. So the coefficient of the x's, there's 3 and 8, so that's already different. and the coefficients of y is positive 2 and negative 3. So none of them are the same. What we need to do here is make them the same. Okay. So it says here coefficients don't match, therefore we need to multiply the equations by a common factor to make them match. Okay, so we need to get these coefficients somewhat similar. Looking over here, if coefficients don't match, you multiply the whole equation by a common factor. Okay, so for this one, what it's doing is multiplying equation 1 by 3. Okay, so that means everything in equation 3, every term needs to be multiplied by 3, which you get here. Then equation 2, if we multiply everything by 2, so every term by 2, you'll get this one. The reason we've done that is now we have the same coefficient for y. Okay, it both has a 6, and that's great because now we can do the elimination method. However, we've got different signs, which means we need to add them together. Okay, so with our new equations, so we've numbered them 3 and 4 now. Okay, with those new ones, we now add them together, which is the point down here. Add them together and you'll get 25x equals 12.5, and then you solve for x. Once you get x, you put it back into the equation to get y, which is here. Okay, if you want to test them out and check that you got it right, you can substitute it back into one of the equations, and then don't forget to state your solution. Alrighty, so it's a big chapter, so exercise 3J. Feel free to obviously rewatch this video, and there's some other videos from Khan Academy that you can look at too.